For this problem, we're going to be using the general equation for the electric field of a solid disk, but we will not be covering the derivation of that equation. So just given the equation, we have the electric field of a solid disk in the z direction, which is a point right above the disk, is equal to the charge density on the disk divided by 2 E naught multiplied by 1 minus the distance above the disk divided by the square root of the distance above the disk squared plus the radius of the disk squared. So it's kind of a long, complicated equation. To draw a picture and to tell you what the variables mean, basically imagine a disk of radius r, and you're looking at a point directly above the middle of the disk at a distance of z. So this equation does not apply for any other point that's not directly above the middle of the disk. Let's write out all of the variables or the parameters that the problem stated. The radius of the disk is going to be half of the diameter, so it's going to be 0.05 meters. And I want to get it into meters because it's always safe to just get everything in SI units so that the equation holds the most true and that the answer will be in SI units as well. The sigma, or the density of charge, is going to be equal to the amount of excess electrons multiplied by the charge of each electron, and then you divide it by the area of the disk. So the total charge on the disk is going to be the 10 to the 11 electrons multiplied by the charge of each electron, which is 1.602 times 10 to the negative 19 coulombs. Now you're going to divide it over by the area of the disk, assuming that the disk is infinitely flat. So it's going to be just pi r squared, which ends up being pi times 0.05 squared. And I'm going to go ahead and just put the meter squared as well, so we have the units. Calculating this ends up being 2.04, and I'm going to just put the E notation, -6, and it's going to be coulombs per meters squared, and that's the units. The distance above the disk is stated in the problem as 1 millimeter, so that is the same as 0.001 meters. And the permittivity of free space, or vacuum permittivity, is 8.854 E -12. And the units are a little complicated. It's going to be seconds to the fourth amps squared divided by kilograms meters cubed. So this is all going to work out in the end when we solve the equation. So going back to the original equation here now with all the parameters given to us and written down. So we have E is equal to sigma 2 epsilon naught 1 minus z over root z squared plus r squared. And to calculate it, let's try to make it easy by just calculating each component individually. So the calculation of this ends up being just 115,202, and just kind of give as many significant figures as you think is reasonable. This is just going to be 1. And this is going to be 0.0099995. So now what we're going to do is we're going to first calculate that, and then we're going to multiply it by this. This ends up being 114,050 newtons per coulombs. Okay, and if you do the units, they will all end up working out. If you want to get into two significant figures, let's go ahead and do that by making it 1.1 times 10 to the 5th power, since you had to move the decimal place over 1, 2, 3, 4, 5 times to get here. And it's going to be newtons over coulombs. That is your final answer.